Hello children, today we will learn about the new type of relation, which is the transitive relation. Till now we have learned about the symmetric relation, the antisymmetric relation as well as the reflexive relation. So let us see what is the definition of the transitive relation. So let A be any set and a relation R on a set A is said to be transitive if AB belongs to R, BC belongs to R, then it says that AC should also belongs to R in order to have the relation is as the transitive relation, right? So if AB is present in the relation, then if AB belongs to R and BC belongs to R, that means that A and C is also present in the relation R, correct? Then only we will say that the relation is transitive. And the transitivity fails only when there exists ABC such that AB belongs to R, BC belongs to R, but AC does not belongs to R. That means if both the pairs are present in the relation, then we will check whether the third ordered pair, which is AC, should be present in the relation. If only one of these relations are present, then we will not say, when one of these ordered pairs are present, then we will not check for the transitivity. If and only if these two particular ordered pairs are present, then we will check for the third ordered pair whether it is present or not, right? If it fails, then the transitivity fails. We will check few examples in order to make the point more clear. Let A is 1 2 3 and R is a relation on a set A. So this is the matrix representation of A cross A for A is equal to 1 2 and 3. So let us go ahead with the first example. So relation R is 1 2 and 1 3. So you see, we will check for each ordered pair, right? We'll start with 1 2. For 1 2, now for 1 2 order pair, this is, let us say this is A, this is B. So we will check for B and C. So we will check whether any order pair start with 2. So over here there is no order pair starting with 2. So the transitivity passes for this particular order pair. For 1 3, again we will check whether any order pair is present with the number 3. There is no such order pair, so we will say that the relation is transitive, correct? Now for the second example, for R is equal to 1 2, again no order pair is present starting with 2, therefore we will not check for the transitivity, the relation is already transitive, right? For 1 1, again there is no such order pair, only 1 1 is present and the diagonal pairs are allowed in the transitive relation, right? So basically for 1 1 they are the reflexive pairs, the diagonal pairs, they are also allowed in the transitive relation. So yes, we will say that the relation is transitive, correct? Again for R equal to 1 2, we will start with the first order pair, and for 1 2 we will check whether it will whether any pair starts with 2. So yes, there is a order pair with 2, which is 2 1. Now if this is A, this is B, this is B, this is C, then AC, which is 1 1. So 1 1 should also be there. Yes, we will say that 1 1 is there. So for this particular order pair, we will say that the relation is transitive. But we have to check for all the order pair, right? So we will move ahead with 2 1, right? With 2 1. Now for 2 1, I will say, I will remove this. Okay. Now for this particular order pair 2 1, this is A, this is B. So we have to find out any order pair which starts with number 1. So yes, we have 1 2. Now this is B, this is C. Now which is AC? AC is 2 2. But over here in this relation 2 2 is not present. So we will say that the relation is not transitive, right? So this relation is not transitive. How we will write this particular thing? We will say that since 2 1 belongs to R, then 1 2 belongs to R, right? But what is but we will say but 2 2 does not belongs to R, therefore the relation is not transitive, right? Only one example is sufficient to fail the transitivity, correct? Now we will move with the fifth example, which is 1 1 2 2 3 3. We do not have any problem with the diagonal pairs. They are allowed in the transitive relation. So yes, this is a transitive relation. This particular relation was reflexive. This particular relation was symmetric. This was anti-symmetric also. This is a transitive relation also, right? Now for the universal relation, this is A cross A. In A cross A, we see that all the type of diagonal pairs and as well as the non-diagonal pairs are present. So all the transitive pairs are present for each pair, right? For 1 2 and 2 3, 3 1 is there, right? Or 1 3 is there. So all the ordered pairs are present. So yes, this relation is a transitive relation. For R is equal to 5, which is a null set, we do not have any ordered pair to check for the transitivity. So we do not have any ordered pair for which the transitivity fails. So we will say that yes, it is a transitive pair. So the definition of transitive is conditional. If we have the ordered pairs, we will check for the third order pair. If we have AB, if we have BC, then only we will check for AC. If we do not have any ordered pair, we will say we will not check for the transitivity. The relation is transitive. Correct? Now points to remember, the only we have one point over here. The relation is congruent to on a set of all triangles in a plane is a transitive relation. So it is very simple. If let us say we have got one triangle like this and one triangle like this, AB, and we have got another triangle. So all these three are the right angle triangle. So if we have A which is congruent to B and if we have B which is congruent to C, then obviously A will be congruent to C. So it is as simple as that. Therefore, this particular relation is congruent to is a transitive relation, correct? So this was a brief introduction to the transitive relation. In the next video, we will continue with the equivalence relation.